Chapter 2.5, solutions by substitution. So we have this equation here, y dx is equal to 2 times x plus y dy. We realize that we need to use some sort of substitution to solve this, as the equation is not exact. And in addition to this, we can't use the separable method nor the integrating factor. Right, so what I like to do first is I like to write everything on one side of the equation. So let's do this thing here. Let's say y dx plus brackets negative 2x minus 2y dy all equals to 0, right? So from here, what I want to do is pick some sort of substitution method. So either I'm going to use x is equal to uy or y is equal to ux. The way you choose it is you pick the term that seems simpler to you. And in this case, we know that over here we can call this m, and we can call this thing here n. And therefore, since we realize that m is a lot simpler than our n side, we're going to use this following substitution right here. Okay, so now this becomes y times dx, which we now call u dy, plus y du, all added to negative 2 times x, which we said was uy, minus 2y dy. Let's get rid of this. All equals 0. Okay, let me go get my eraser. Let's get rid of the substitution because we already applied it. So really simply, we could write this thing here, uy dy plus y squared du, subtracted by negative 2 uy dy, subtracted by negative 2y dy, all equals 0. Okay, so now what I can do is I realize that I have a y that repeats on every single term over here, and I have a 0 here. So what I can do is I can cancel out the y. I could cancel out one of the y's here because it's a y squared. Get rid of the y here, get rid of the y here. Write this thing as u dy plus y du minus 2u dy minus 2 dy all equals 0. Okay, so now that I have this new form over here, really simply, this becomes a separable equation. So let's erase this thing here, give us some space, and let's go and write this on top over here. So let's keep all of the dy terms together and all of the du terms together. So I could write this thing here as y times du, as it's the only term of du here, plus u dy minus 2u dy gives me negative u minus 2 dy equals 0. So now you see that this could be a separable equation. So what I could do is write the following. I can move this term on the other side over here. So I get y du is equal to u plus 2 dy, but I have the dy's and du's inverted, so I need to divide this entire thing on this side here and this entire thing on that side there. So I end up with 1 over u plus 2 du is equal to 1 over y dy. All right, and this becomes a separable equation. Very simple. Let's write this thing over here as, you know what, let's keep the y's on the left. We'll write this as ln of y, or absolute value of y. You could specify that y is greater than 0, is equal to ln of u plus 2, u is greater than negative 2, plus some value of c. Okay, I can raise both sides to the power of e. So I could say e to the power of ln of y is equal to e to the power of ln u plus 2 plus c. Okay, let's erase this here, give us some more space. If anything, you could just pause the video and recopy what I was writing there. So e to the power of ln of y just gives me y here. E to the power of ln of u plus 2 plus c. I could, as we did in the previous example with the powers of e, I know that e to the power of ln plus 2 plus c is the same thing as saying e to the power of ln of u plus 2 times e to the power of c. And we know that e to the power, a constant to the power of some constant is also just going to be some constant. So I could say that also e to the power of ln of something is just going to be that something. So y is equal to u plus 2 all multiplied by c. Okay, so then what I could do is also bring back that initial u substitution that I did. So since I said that x was equal to uy, I could say that u is equal to x over y. All right, so y is equal to x over y plus 2 all times c. And you could very well leave the answer like this, but if we wanted to simplify for y to keep it alone over here, what we could do is the following. We could divide by c on this side here, right? And divide by c here, and we know that 1 over c just gives me c. So I end up with cy is equal to x over y plus 2. And through some manipulations of this equation by multiplying the entire thing through by y, I can say cy squared subtracted by 2 times y is equal to x. Now I have all my y's on one side and my x's on one side, and I can write the final answer.